One. Well, thank you. I would like to give some update about the drainage research in North Dakota. As you can see that this is a snow water equivalent map for this week, and we don't have a lot of moisture in the South Valley, North Valley. It's probably just around Grand Forks we have some moisture. That's probably when drainage will work the best. Of course, the purpose here is to show you where the North Dakota Drainage Research is located. So, of course, the first one is in Fairmont, Richland County, North Dakota. That's located in the corner of North Dakota, South Dakota, and Minnesota, where I work on that side. Well, the second side is just north of Fargo, where my colleague Hans Cantel is working on drainage, control drainage, and no drainage comparisons of the crops, especially from the economic perspective. And the third side is a research done by Tom DeSade in the soils, especially looking at the soil salinity effect that with drainage and on how to aid different amendments to reduce the infiltrate and reduce the penetration or the drawback costs, for those soils. And the newest, the last side is a share farm in North Dakota, where Eileen talked about all those soil hills research is happening on this side, and tide drainage is one of the components they are working on. So for the research in Fairmont, where Tom and I and also colleagues in my department, soils, are working on, particularly looking at the water balance and soil quality and water quality. And right now, Ali Rashid, my PhD student, is particularly looking at the crop evapotranspiration in this side. Of course, drain mouth simulations are always in our mind if we can get it to work. So this is a field that we have a 100 acre in the south side of the ditch that's tide drained, tide drain, control drain, and sub-irrigated. Where the north side of the field is 200 acre is untiled. It's the same soil, same landowner. And I do put a table here to show you the clay percentage. As you can see that we have a 30% of clay. So this is a heavy clay soil, not like soils from other region. And this is a figure from the transforming drainage side. As you can see, this is one of the two sides that in the transforming drainage project. And then we separate the field to 50 acre drained and sub-irrigated and controlled by two sump pumps. I know a lot of you probably feel like, what is a sump pump? Basically, as you can see that it's a big sump, a big hole on the ground where you have a pump system there that pumps the water out and then pump the water in if you do use the sub-irrigation. And then we have a different sensors located in here. As you can see, we have a drainage measurement, irrigation measurement, and also rainfall and snowfall. And we do a bi-weekly sampling on this site. And then, of course, we monitor the water qualities because that's the concern for the state. So we monitor the water qualities at the sump pump, the two sump pumps, as well as the surface water. And actually, we don't see much of the change in the water qualities from the sump, but we do see a lot of change in the surface drainage ditch. That's an indication that more fields are tiled in this area than before. So with that, here we have 10 years of data. As you can see that our rainfall is decreasing, even that's not that much. However, our drainage flow actually decreased a lot, probably only 1/5 of what we started in 2008. as probably contribute to the controlled drainage or some other practices. We also look at the water qualities. We put all the data together and we couldn't find any statistical difference. So we separate the data to the springtime. Remember, we're in North Dakota. We always have snow. So when you have the snow and then and then the freeze and the sun, and so a lot of things has been changed. That's why we separate our drainage to spring drainage and then to the fall drainage. So looking at the spring drainage, and we can see that the red color increase is an increasing trend, while the blue is a decreasing trend. As you can see, our salt-related parameters have a decreasing trend from our sump pump. Well, that's really good. So, and then we're looking at the surface water quality parameters, especially in the fall. We do see an increasing trend, especially for the salt-related parameters. Where nitrate is kind of elevated, a small increase in the fall. So that's something kind of will bring to the Red River Basin Commission the nutrient reduction strategies that if you do want to reduce your nitrate, you probably want to target something that's in the fall instead of in the spring. So that's a good result. Of course, we have more, but one thing we always care is the yield. So we always expect a 20% yield increase due to sub-irrigation. And of course, this year, 2017, was a big surprise. Yes, there are 14% increase compared to the county average, but it's lower than the Android field. And of course, when you do research in that field, whether it's your reason or not, you're the one to be blamed because you do research in farmers' field. So when we got this news and we are scared, okay, I am really scared. So we went back, we got these drone photos about the field that's high drained and sub-irrigated. And I look at this photo, it's devastated, okay? And so we went back and do a lot of investigation. But however, my colleague, Tom, he has a very sharp eye. He said, oh, look at this picture. It's not just your sub-irrigated field, along the ditch have that, lower yield or damaged crop. Even in the entire field, the crop is also damaged along the ditch. Think about that, something happened there along the ditch. I said, okay. But anyway, so we went back and we took tons of pictures. We did the topography survey. We saw maybe the lower depression point. We took tons of soil samples, of course. We want to find out whether it's a salinity-related issues or it's a salinity-related issues because the sub-irrigation water we use have a SAR that's about 6. So it's a problem water. So we did everything we could. We have several meetings. At the end, we found it's a water issue. So why is a water issue? Well, this is our typical field that, we have a May, we have a lateral. So lateral drains to the May, and then when we do sub-irrigation, we back up the water to the field. Theoretically, we say, when we raise the bar, the water will go back. That's true for most of the soil. But remember, we have our soil is heavy clay, 40% for clay. And especially when it's close to the outlet, the May is 6 or 7 feet below ground, and also close to the outlet is a higher ground instead of a lower ground. But that's where our legal drainage is located. So when we bring the water table up, the water will go back to the field as expected. But then remember, as I said, in reality, what is happening is the water is accumulated near the May. There may be 1 or 2 of the laterals the water gets through. That's where see the bare soil ground. And of course, as I said, yes, we have a sub-irrigation here. You can blame us. But what about the field next to us? They don't have a drainage. They also have a damaged crop. So and we suspect there are two reasons. One is the soybean variety he used is a new variety. It has not been used anywhere else. It's a brand new variety. Another thing is when you dig that drainage ditch, you do have a clay soils that build up along the ditch. When you have that heavy clays, it creates a barrier that's somehow near there, then create waterlogging conditions along the ditch. So that's something that we investigated. And of course, the next question is, what are you going to do? You're doing research there. So we can redesign the sub-irrigation system. We have all the information. Of course, whether the farmer will listen or not. We can use small controlled drainage structures. Yes, there will be additional $1,500 cost for each one. We can change the irrigation methods, use surface irrigation, or we can irrigate less or do not irrigate, and we just reduce our problem. Or we can plant a different crop, a different variety. There are 100 different ways to solve this problem, but which one is accepted? So we get the issues in our small head, we solve it, and then now we have issues here. We have been doing research there 10 years, but this is the first time we solve the issue. Anyway, that's the research. I apologize for my colleagues that don't have time to talk about their research. So this is Hans Kendall's research is mainly compare the water table and crop yield difference among these different varieties between tiled and untiled. And Tom DeSada's research on soil salinity and salinity with different amendments. And the last research is a share farm, and I have a YouTube video here that is very nice video. So with that, I am selfishly stopped here. Any questions?